Dear students, I welcome you all for the online blended learning, especially for the honors registered students for the course Warehousing Automation. So to learn the course, there are 10 chapters are there in the first unit. So almost we have half of the course, that is half of the unit we have completed. And now we are in the 7th chapter, types and benefits. So before we get into the further things, we'll just summarize what we have learnt in the earlier presentation. So summarization is like this. Initially, we discussed about the manual challenges what we face in a warehouse, and prior to it, we learned about the different types of warehouse processes and the challenges, and we learned about warehouse automation. And in addition to it, we learned that there are two types of automations are there. The first is digital process automation, and the second thing is physical process automation. So digital means it is going to completely govern with respect to data, algorithm and performance based oriented, especially with respect to data. Then physical means here it is going to discuss purely with respect to the movement of product within this particular aspect has to be considered within the warehouse on a majority of the scale. Of course, little bit we focus on to the external case, but still majority it is going to be on the physical, that is within the warehouse. And this is the roadmap for it. So towards warehouse automation, so initially we kickstart with a robot in a physical perspective, and similarly any smart device from a digital perspective, and at the end the hierarchy will take us to a complete warehouse automation. So here we just learned one particular thing called as GTP, but we never dwelled into it in a very deeper case, and this presentation will get into the types. So this is with respect to types, GTP systems. So how various types of automation is going to be helpful with respect to the activity, or what all are the different types are there based on which we can select upon the need, necessity will determine what is the automation type essential. Now, there are four different types of automation levels available. So again, I emphasize we have got four types. All the four need not to be chosen at day one. So it is something like in a sequential case. Initially, we can coin upon one basic case, then we can gradually we can get it into automated. Of course, the ultimate aim will be an advanced warehouse automation, but still the level is going to help us with respect to the sequence. So the first is going to be the warehouse basic case, basic warehouse automation. Then the second, warehouse system automation. Then the third, mechanized warehouse automation, and finally advanced warehouse automation. So now we'll understand what is the difference between all these things from an application perspective. So basic means here we are going to introduce either one. It might be either DPA, digital process automation, or it will be PPA, physical process automation. Some cases, if you want to do both, then it is going to be with respect to the second category. So first category, any one. Second category, yes, either cases or both the cases will be selecting upon. And mechanized means purely it is going to be PPA, physical process automation. And finally, complete, A to Z complete with just human input, human intervention. Majority of the cases will be taken care by the automation technologies. So earlier we discussed automation is not one technology, it is going to be cluster of technology that we discussed earlier. Presently, there are four types of automation, warehouse automation was there, but still we don't confine to four. Basically, based on the requirement, the need, necessity is going to determine the quantum of automation involved inside a warehouse. So we can't restrict. We don't, as an user, as an individual, we don't restrict, or we need not to restrict. If you want to do one simple task for automation, is we are free to do for it. So there are several types are there. Just for the case of clarification, we just broadly distinguish into four different types. So the first is basic, then warehouse system, then mechanized, and finally advanced. But whatever the thing we go ahead with, the ultimate objective is to minimize manual tasks. So speed up the process from order receiving till shipping, till you get the order and the component gets or the product goes out to the market. Till then we need to minimize the manual intervention as well as we need to minimize the time. So this is what the main essential is all about. So whatever the automation we level go ahead with, so this particular task is not going to change. Earlier slide, we just discussed about the various levels of automation. Based on the need, based on the necessity, we can decide upon the type of automation what we wanted. In other cases, the level of automation is determined based on the need and necessity. Also, some cases, the investment part also has the right to determine what type of automation we just wanted to incorporate into the industry. So these all are the different things. And now we are getting into the types of automation. What are the different types of warehouse automation? So the first, even in the earlier presentation we just discussed about it, the first is going to be goods to person. So goods to person is going to be the first type. So in short it is called as GTP. We'll see all the further things in the upcoming slides. Then the next interesting part is ASRS, automated storage and retrieval system. Then the third, AGV, automatic guided vehicle. Then the fourth being AMR, autonomous mobile robots. We'll see the differences between AGV and AMR. Definitely you will have doubts, don't worry, we'll get it clarified in the upcoming discussions. Then the next is pick to light or put to light systems. Voice picking and tasking. Today it is gaining high importance in this regard thanks to the development of several AI technologies. And finally, automated sortation systems. So here automatically it is going to sort. We will see everything in the upcoming slides. So earlier we discussed about the levels. There are 4 levels of automations are there, and now we are discussing about the types, different types of warehouse automations. Now the first, GTP. So GTP is an acronym, and when it is abbreviated it is going to be goods to person. Goods to person fulfillment is one of the most popular methods for increasing efficiency and reducing congestion. It's a basic fundamental things which is going to help us for the case of increasing the efficiency. This category includes conveyors, carousels and vertical lift systems. When properly applied, GTP systems can double or triple the speed of warehouse picking. So now we'll understand it step by step. This compound statement will break them into small components. The first, the basic thing here it is, we have got a warehouse, big warehouse is there, and the warehouse is completely loaded with various products what we meant to take them to the market, and now we have got the orders. As a person, before you dispatch, we must know where the product is and how to bring back the product. So this is what is highly essential. Now this particular task alone, see there is a shelf, the shelf has been completely loaded with the product. As an individual, I just wanted to get the product to my hand. Now only for this task, we need to depend upon some system, and that is called as GTP system. How this may be done? Either a conveyor or a carousel or some sort of vertical lift systems might be employed. So here the task is very simple. Completely the goods are loaded inside the factory, that is warehouse. We just wanted to get that product to a human hand. Human hand means in this case we assume that the packing, everything is done by human case, manually everything is done. Only thing is they just wanted the product to reach their workstation. So if this task alone if you are able to do, so what the research says is double or triple the time of the warehouse speed picking process can be on a larger scale, that is thrice or twice it can be increased. Why? Because this is one of the crucial tasks. Say identifying a product, picking the product and bringing the same to the human for the case of packing means that's a crucial task, and that if you are able to automate, then that system of level of automation is called as goods to process system or goods to person. In short, it is called as GTP. The first case was with respect to GTP, that is, goods were available in the warehouse, and as an individual, we just wanted to get the product towards our working area for further processing, that is, packing and dispatch. Now, arrangement would have been done manually. In the racks, we would have arranged manually. So that is the drawback in the earlier system. Now ASRS. So there are two terms combined together. Automatic storage, second part, retrieval systems. So now both has been brought together. That is, it's a GTP type but extended even to storage. That means the product will be there. You ask the system to go and store to one particular requisite area, and you retrieve those products whenever we have a need. So this is what we need to go ahead with. So always the engineering philosophy is convert your weakness into strength. Work on the negative point so that that negative can be an opportunity of solution, and that can be made into positive with respect to time. So here ASRS means you ask the system itself to store in one particular location, and you ask the system to bring it back to an individual, that is GTP category, when necessary. So here both the activities takes place. So here we will be having some sort of sophisticated setup like metal carrying vehicles, tortoise shuttles, mini loaders to store as well as to retrieve the product. Storing also will be done by the system, retrieval also will be done by the system. So where it is used means it's very simple, where you have got high volume production based warehouses, where huge volume comes into picture with huge diversity. This is another important factor. So where you have got several constraints, that's the case where we go for ASRS. So now this is one factor which has to be considered upon. You have got only hand few numbers with very little constraint means it is very obvious that we are not supposed to select the ASRS category. We need not to want, because our restriction is only that much. We don't have huge volume. On the contrary, when you have got huge volume, it becomes mandatory that we go for ASRS category. Now, in the earlier we just saw about tortoise shuttles. See, these all are the tortoise shuttles. It is nothing but it is going to move to and forward in a particular pattern, only to and fro, nothing else. Why it is called particular pattern means it will go and stop there. So now you can see this is a four-way shuttle. Likewise, the first direction is going to be the front, and this is going to be the second direction. So when it comes and stops somewhere at one location, you have got a product within it, so that can be stored inside the product somewhere here on the right side, something like this. So it can be stored here, and if you want to bring back, again this path will be used. So again it will be loaded here, and at the end we can take it out. So there are four paths are there. We can use these four paths, and then we can think of using for the case of ASRS. So now location is also possible, storage is also possible, loading and unloading is also possible. So there are totally four activities what the shuttle can be used to perform. Therefore it is called as tortoise shuttles. The next, automatic guided vehicles. In short, it is called as AGVs. So, this class of mechanized automation has minimal onboard computing power. These vehicles uses magnetic strips, wires or sensors to navigate a fixed path through the warehouse. So now what is this AGV is? See, earlier we saw about various two things, and now this particular thing is going to be a simple vehicle. It is going to get some sort of guidance idea. So this guidance will be given either by a magnetic strip, that means a magnetic strip will be laid on the shop floor, and this is going to be a simple line following machine. It is going to follow the magnetic strip what has been already levied onto the floor surface, or it will be some sort of wires, magnetic strips or wires or sensors, a line following robot to be precise. So it is going to navigate along the path what has been specified. So now what will happen is, can it take its own path means obviously the answer is going to be no. It is not in a position to take out the path on its own. So that is the drawback with this. We should predefine the track on which this particular AGV is supposed to travel. Now, AGVs, what is the problem with AGVs is it is only applicable for large case. For simple warehouses, no, this is not possible. Why? Because the turning radius. See, AGV has its own size, say at least by half a meter wide by 1 meter long, and thickness might be say some 400 mm. Now, this particular trolley like structure should get a turn radius. So, turn radius means we need to give sufficient amount of space in between. So that is possible only for the larger case. For simple warehouses, no, it is not highly recommended. So that's the biggest problem is here navigation. So complex warehouses with lots of human traffic and space constraints are not good candidates for AGVs. If you have got one particular area which is very congested by means of frequent human movement means because the AGVs are not capable to sense the hindrances. They just follow the path what you have given. So that is the drawback with this particular material handling system. Now, the next fourth one, autonomous mobile robots. See, earlier we saw about AGV, automatic guided vehicle, which has got a track being guided by means of a user, maybe a magnetic strip, a wire, or paint. Even paint is also applicable. So we are going to just provide. And for the large cases, it is only applicable. For small cases, it cannot take up the turning radius is not appreciable way. And other thing is frequent disruption by means of human movement. Again, it is not recommended. Excuse me, it is not recommended. Now coming for the next, autonomous mobile robots. So whatever the problem we faced with respect to AGV is completely overcome here. So what is the first thing? There should be a guide mechanism. Now let us understand, observe the guide mechanism. We have got a painted strip or magnetic strip being permanently fixed onto the shop floor, and frequently human come in here and there, human crisscross the path, and other cases even some other metal handling movement will just pass here and there. So what will be the condition of the tape with respect to wear and tear? So obviously it is prone for wear. So with respect to time, yes, definitely it is going to wear out. So once the strip is getting worn out, obviously the performance, the robot, that is AGV, will not be in a position to sense properly. So there will be some sort of lag can be observed. But now the same thing is being overcome here, and AMR is going to completely works well with respect to this. How? Because it is going to use GPS system. Something like Google Map it is going to use. And we need to specify only the from and the to point, not the track or the path like the way what we have given in AGV. In AGV, not only from, not only to point, even the path also to be specified. But when you see with respect to autonomous mobile robots, no, it is not at all necessary. So it will be a web-based application by means of GPS, something like Google Map. So where we are going to define the from point and we are going to give the to point. Now there might be question how the robot or the device will maneuver with respect to the path means it has a very good laser guidance system. So the sensor is called as LIDAR. LIDAR, it's an acronym. So LIDAR sensor will perfectly guide, and any hindrances like the earlier case, if frequent human intervention is there means AMR is highly capable to sense the intervention and it will stand still as such. It's not going to come and collide with the hindrances. So even it is capable to take up the dynamic environment with respect to the n number of times there are hindrances in the path, still AMR is going to work very well. And the other important thing is the radius, the turn radius is going to be the least. So therefore, wherever it is highly impossible to use AGVs, the same cases can be used in a very successful case when we go ahead with AMRs. Because of two things, web-based guidance number one, and number two, LIDAR sensor, onboard LIDAR sensor, which is going to identify the hindrances in the path. So the advantage is it is very easy to program, dynamic to program, because we are not going to specify the path, we are going to specify the from to point through web-based application which is connected by means of GPS, onboard LiDAR sensors are going to ensure us the smooth navigation. The next, pick to light and put to light systems. So these systems are basically mobile barcode scanning devices synchronized to digital light displays to direct warehouse pickers where to place or pick up selected items. They can dramatically reduce walking and packing time and human error, reducing the human error in high volume situation. So this is very simple. That is, it is going to have a display unit. It might be a HV or it might be AMR, and it is going to have simple. It is going to have a display unit which is going to tell what product is on board, where it is going, from which point it is coming. So likewise, it is going to give all sorts of data. So that is what is pick to light and put to light systems. F, voice picking and tasking. So today, with respect to the advancement in AI, we have got several features. Say for example, even a Google Sheet is having, we need not to type. We just talk. It is going to recognize the speech and it is going to convert the same into words. So today technology has developed so much. So here is also same thing. So rather than going and typing, for the product name might be quite long, or some cases where human is again prone to do some sort of errors, but here voice tasking, everything is going to be by means of voice command. So only thing is we need to have a very good headphones which is sensitive to capture in a very precise way the voice commands what we go ahead with. So the system itself is capable to pick up all these things based on the input what the user has given, and it is going to select the optimized path in order to ensure the smooth transit within the warehouse. This method eliminates the need of handheld devices like RF scanners, that is RFID scanners. So pickers can concentrate on their task with improved safety and efficiency. See, since the command is going to be given, what product has to be chosen is going to be given by means of voice command. So the scanners and other things are eliminated. That's what it means. Automated sortation systems. Sortation is the process of identifying items on a conveyor system and diverting them to warehouse location using RFID barcode scanners and sensors. So how to understand this? Say for example, on a conveyor system, there are some number of components being transported from one point to another point. Now what is the requirement here is certain products, say with certain specifications or certain numbers, should go to east side. East side means east districts or something like that. So another 5 numbers should go to some other area, geographical location. So automated sortation system will take care of that based on the barcode what we have given. So certain numbers, say odd numbers should go to one side, even numbers should go to other side. So something like that we can decide upon. The routing rule can be given. We can give the routing rule. So companies use automated sortation systems in order fulfillment for receiving, picking, packing and shipping. So based on say something like pin code, the items has to be segregated. Yes, this system will do good. Or based on area, what we saw in the earlier presentations, like the way how a smart shelving activity is working, like that, yes, it is possible. So only thing is the data has to be present onto the product by means of AEDC device we can easily capture. So increased warehouse throughput, better resource utilization, reduced labor, operational cost, improved customer services, reduced handling and storage cost, reduced human error, minimized manual labor, or the visible tangible benefits what we can obtain the moment when we adopt warehouse automation. So first thing is directly the benefits what we can tap it out is all these things. Indirectly there are so many things are there. Just to prioritize, these all are the important benefits. And now the list goes on. So increased productivity and efficiency, improved employee satisfaction, enhanced data accuracy and analysis, reduced stock out events, optimized warehouse space, greater inventory control. So by adopting these things, these types of warehouse automation, these all are the potential benefits what we can tap out of it. And still more with respect to ergonomics. So improved workplace safety, fewer shipping errors, reduced inventory loss, enhanced material handling coordination, improved order fulfillment and accuracy. Now challenges. Like a coin, there are two sides over there for a coin. Likewise, when we adopt warehouse automation, there are so many benefits what we have listed out earlier. Simultaneously, there are so many challenges out there. Let us see one by one. High upfront cost, that is nothing but investment cost. Initial investment cost is going to be on the higher end. So complexity of integration. So we need to have some sort of high skilled instrumentation engineers to interface the hardware, the software, the sensor, the controller, everything has to be interfaced. Yes, we need to have some sort of skilled force with respect to this. So need for specialized skills to operate all these systems. Apart from integration, the moment it has been integrated, for the case of regular operation and regular maintenance, we need to have skilled people. So risk of technology obsolescence, yes, this is very evident. See earlier, still India has not completely adopted itself for AGVs. Today, foreign countries AGV is almost obsolete, that is outdated. Today the technology is outdated and AMRs are preferred inside the industries. But country like India, where AGV itself is getting introduced right now, but global standards, when you see, AGVs are almost outdated and AMRs finds its position there. So such, yes, today whatever the technology we feel as superior, over a period of time it is going to become obsolete. So what is the takeaway here is, we should be in a position, we should have a proper rapport that we should simultaneously we should update the technology. So potential for disruption, if something, some major issue comes into picture, means entire warehouse is going to get into standstill condition. So disruption chances are there. Dependency on technology, yes, we need to depend on technology. Maps, Google Maps or something like that, you go for third party apps, we need to prefer, we need to pay them. That company might exist, may not exist, or they may change their policies with respect to time. So always we should depend on technology. So workforce displacement concerns. One team of people would have been nicely trained, they may not in a position to stick to the organization. We can't ensure it. They might get a very good opportunity from their perspective and they may switch over with respect to time. So that problem has to be thought of. So before we close, now let me summarize what are the things we dealt in this regard. So there are different types of automations, warehousing automation techniques are there. So right from basic things till the advanced categories we just discussed, and finally the potential benefits of 20 plus numbers we just saw and 10 plus numbers of challenges also we saw. So these all are the challenges which are going to pave a very good opportunity with respect to research or with respect to employability or career in the near future. So any doubts, as usual, please note down elsewhere. We'll meet during offline classes and get the doubts clarified. So thank you all.